Welcome. Today I'd like to talk about different kinds of diagrams that you can do and should do for your projects, and also one in particular, which is a fire and life safety diagram, eventually becoming a fire and life safety plan that goes on your code analysis sheet. And all of these diagrams are basically simplified drawings, typically floor plans or sections or axonometrics that explore one particular aspect of the project that you're working on. And you can do them in a number of ways. You can, of course, do them by hand. Obviously, that requires you printing a drawing out, having a neat hand drawing style, and then scanning them back in. You can also do them right in Revit and create. I typically do this by creating line styles that are what I want for different aspects of diagramming. You can add line styles that are really thick and have color to them. The advantage of this is that if you are putting the drawings on your code analysis construction drawings sheet, then the drawing is already in Revit. If any changes happen along the line to your design, the code analysis drawing will update as well. You can also use Adobe Illustrator, and of course that's the most stylish way and is the best for schematics when you're probably not using Revit's page layout sheets. So let's talk a little bit about a couple of different types of diagrams. And first, and possibly the simplest, is a plumbing diagram. And I just have some examples here. On the left side is a two-story project where the main goal here is to determine if, first of all, the vertical plumbing lines up with the first floor and second floor line up with each other. And then once you have that vertical alignment, how do you get the water and the waste to each space that needs it? Obviously, you need to be at the point in design, and here, I've cleverly written in toilet in a giant room, which doesn't look like a toilet, but again, the idea is if that's where your toilet is, you'd need to have a horizontal run for the water supply and a run going the opposite direction for the waste pipes. And then you want to make sure that the wall that you stick the waste pipe in and the supply lines line up. It's particularly important for waste lines because they're just much thicker pipes. But even supply lines, it is nice if the walls line up. Not a complete disaster if they don't, because you can run plumbing above the ceiling or below the floor or in the floor. And here's an example on the lower right of just a floor plan view. And just again to show you different ways of producing the graphics, that all of these on each of these that are a floor plan view were produced using Adobe Illustrator. On the left, shockingly, they were drawn using PowerPoint, of all things. Probably not the best graphics software out there. Anyway, even things like sprinklers in schematic design, you don't need to know where every sprinkler head is. That's too much detail. But what you do need to know is how is the water going to get to the sprinkler pipes, and where are those sprinkler pipes going to run? If you have, for example, an exposed structure, then your sprinkler pipes typically are up above the structure, then that's something you want to know right away, because the sprinkler pipes are going to have to be painted, and you're going to see all the drops for the sprinkler heads. So doing these diagrams helps you decide if you want, for example, just a ceiling to cover that up. Electrical is another one, particularly important when you have multi-story spaces where, maybe a mezzanine or something like that, where the project is exposed, and you can't just run things where the structure of the building is exposed, and you can't run electrical wiring without seeing it. And so again, you'll just want to think about, well, you do need to have electricity in pretty much every space of a project, even if it's just convenience outlets. How are you going to get that power there? And of course, electric lighting and all that is another thing. Frequently, you will have a plumbing chase. You can sneak a lot of the major vertical cabling up there. However, things like the speakers that you might have, security systems, smoke alarms, smoke detectors, all sorts of things, wireless routers, those are going to need to go somewhere. Again, maybe this is what helps you decide you're going to have a ceiling as opposed to exposed structure or something, some alternative to exposing all of this misery. Anyway, typically electrical supplies do have accessible on the main spaces an electrical control room or panel room somewhere. It's particularly important when you have more environmentally advanced systems where all the systems are monitored from like a building control room. That's a great idea, but you have to kind of plan that in your project. So, and again, there's the Illustrator drawn version. Not actually sure I like that particular line type. But that's what they chose to do. This one's a little more stylish, I think. Here, the HVAC plan. Again, it does require knowing what kind of HVAC system you have. Now, in the gymnasium that we've been looking at and the pool project that we visited, it was a forced air system, and there is a ducted supply and return, separate duct systems. You don't always have that kind of HVAC system, or if you're working in a project and you diagram it out and you're like, that forced air system is not going to work for us. You might need radiant heat with a makeup air supply, whatever it is. When you diagram this out, if you don't have anywhere to run those ducts, you can't have HVAC that uses ducts. You'll have to find some alternative system. Again, in any type of project that has a vertical element, you might want to draw a section. I think in our project that would be just Jim Dandy to do. And partly because, again, are you going to decide to have a ceiling which conceals all the ducts? And then how is the supply going to happen? Presumably it's going to happen through supply registers. And then how is it going to get under the mezzanine? Well, this symbol, by the way, is a symbol for duct that is cut through. Hopefully we will run the ductwork under the seating. You see how there's enough space, at least in the diagrammatic way. And then the air will get blown into those spaces below. Presumably there will also be a return duct, which I probably should draw in there as well. And you should do a section for anything that you think is appropriate. I'm showing you the major ones, the ones that are kind of required, but you can absolutely do it anyway. And this is actually, you might say this diagram doesn't tell us anything, but actually it does tell us something, even though it is clearly very, shall we say, diagrammatic, just kind of saying in this space we're going to have general lighting. Now these are actually terms which you'll learn in lighting class versus task or focal lighting, but at least it helps you to think about what kind of lighting you're going to have in that space, and that helps you again determine what am I going to do in terms of ceiling or wall mounted or even floor mounted lighting. Just to, again, strategically think through early on, what am I doing? Then later, as you develop your project, of course you can change. General lighting may not always be the best thing. General lighting being lighting that is not focused on any particular element. You might change your mind and decide you want something more focal, or you might want multiple types of lighting, decorative lighting matched with some focal lighting on different tasks, and then some general lighting just to sort of navigate the space. In our project in particular, and in the one that is demonstrated here, acoustics were important. I'm not quite sure why this particular student combined circulation and acoustics, kind of an odd bedfellows. But anyway, what she is indicating here is that some walls are going to need special acoustical treatment. This particular project was one involving dogs. Dogs bark a lot and are noisy. So obviously in our project it is slightly different, but it is still going to be noisy. You need to do something about acoustics. Again, maybe you draw a section and you say, I'm going to have acoustical ceiling treatments over the entire space. What would that look like, having an acoustical ceiling over the entire space? Is that really what you're looking for? Or maybe you're going to have some kind of other, I don't know, Ripley ceiling or some other material up there that's going to help you out. Or maybe you're going to choose a floor material or wall treatments or wall coverings that are sound absorptive. But somewhere you're going to need to absorb sound in that space just to keep it at a more comfortable level. So anyway, the big things to think about here when you're creating these diagrams are the clarity of the diagram. And I think that last one was a good example of a nice, clear, you can really tell where the circulation is, perhaps maybe arrows indicating where the entry and exit would have been nice. A key really helps with that, having a key that says, oh, these walls are in that case sound absorptive, or maybe the ceiling has a treatment, or maybe you do a section where you indicate a ceiling that's hanging below the existing structure. And the graphics themselves should be clear and concise. If you need to fade out the floor plan, make it a little gray, less than 100% opaque, to clarify it and clarify where these treatments are, by all means, do that. So those are diagrams. Now let's talk about building codes and accessibility. There's a couple of things that you need to worry about in schematic design, and the big thing at schematic design is you are not looking for a high degree of specificity. You're just kind of looking at these overall planning issues that are going to affect sort of major elements where pieces of circulation, entries, exits are, and also if there are any accessibility considerations that need to be addressed that would force you to alter your overall space plan. Okay, so code analysis, and this is straight out of the book. There's usually a sheet that talks about code analysis in a construction drawing set. Smaller projects, you might get away with just a partial sheet. These drawings can be quite variable in how they look and what kind of information is in there. In the example here, they have an occupancy plan, which indicates the sort of uses of each of the parts of the building. These are the overall occupancy groups of the building. They might have an occupancy plan, which calculates the number of occupants. They would certainly have a fire and life safety plan. And in this case, they've even included some accessibility details with dimensions. Here's a different example, a larger project where they have a stacking diagram that describes the occupancy classification. You can see graphically pretty clear what's going on. They did a nice job there. And this also has information about the construction type and how that affects the fire-resistant materials. You know, you can only choose materials that are acceptable for different occupancy classifications and construction types. So this is farther than we are going to get for this schematic design. In fact, this is definitely a construction drawings level code analysis. So for us, early on, there's certain basic information that we're going to need to know, and we're going to do this in class. First of all, occupancy classification. So what type of project is in there? This is the thing. Is it business? Is it educational, or what? And then you'll want to figure out where the location is. The big thing with that is to figure out who the authority having jurisdiction is. so that you know what building code to use. I cannot tell you how many times that is a common error, kind of a rookie mistake, is using the wrong building code. And I won't say it happened to me, but needless to say, it's not uncommon. Anyway, the building type and construction, and again, these are things you cannot change as the interior designer, interior architect. And then if there are any major elements that need to be fire resistant or separations, like a fire separation wall is one of those big things. In our project, it's again, we don't have to worry about that. But then the last piece, the means of egress, that is really important, and it has a very large effect on your project because number of exits and having a compartmentalized path of egress, if it's called for in that project, really affects the way a project is laid out. So you need to make sure you get that right early on. You would not want to have to add things like an extra stair later on or extra doors. Other stuff on that list we'll cover later. So these life safety plans, typically they're really itty bitty. 1/32 of an inch is fine, or 1 to 200 if you're like the rest of the world and you're metric. These are, you can fade out the floor plan so that you can really read the diagrams. In our case, for schematics, it doesn't have to be 1/32 of an inch. Just small is the idea. A few, like 4 or 5 inches across is plenty for these diagrams. Even smaller is probably fine if the graphics are legible. For fire and life safety plans, there's a number of pieces that you're going to want to show. The biggest thing is the exits, right? How many exits do you have? Make sure that they are clearly indicated in the diagram. There are a few other basic constraints that apply to the interiors. The maximum length of travel to those qualified exits. 250 feet is the maximum length unless you have sprinklers, which we probably will not. But anyway, and 250 feet if you do have sprinklers. And then the exits need to be separated by at least half the diagonal. Now, again, in our project, we have some existing exits. We know they're already currently compliant. It's probably not going to be a problem. However, you need to show it. And you want to prove to the building inspector that you are compliant. So what I typically do is I just sketch in where the exit signs are too, use a diagrammatic indicator. That helps me, again, think about, am I having ceilings? Where am I going to put that exit sign so that, a door doesn't swing into it because the ceiling is too low, but it's still visible. So, I'd like to just, remind you all of some of the basic pieces of the means of egress. I know these are terms you hear, but it's easy to forget. The exit access is like a corridor. Okay. Now, in our case, we aren't going to have separated corridors. It's not required for our type of project. But those exit access gets you to either a stairway, or to an exterior wall where you can get out, okay, or a fire separation wall in the case of parts of our project. So there are sub pieces. The stairway itself is what's considered an exit, and the exit discharge is some interior space that you sometimes have to go through to get to the public way. So here's an example from the book of a life safety plan, which I actually find a little hard to read. I think they could have faded out the floor plan a little bit and made those arrows a little bigger and the text a little bigger and blah, 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 blah. But again, it's an example, and they're talking about it shows the routes out of the building. Now, this is a particularly complicated plan that they've used. So, if you're in one of these central spaces, how do you get out from the kitchen? Again, I don't think the graphics do a good job here. This is from some student work. The text is a little small, but you can see graphically, you get a pretty good sense of how you're going to get out of this building. And the diagonal dimensions are what are indicating the separation of exits. So that is measuring the diagonal of the floor plan I think I can read it at 167 feet for the left wing of the building. The central wing of the building is actually a fire separation wall. That's basically a separate building. And the red lines, I believe, are actually measuring the actual distance you'd have to travel from one exit to the other. So if there was a fire in front of one door, you could run to the other door. As long as that's less than half the distance of the diagonal, you're good. Or 1/3 if you have sprinklers. So anyway, and then the green line, I believe, although I think I must have cropped off the key, the green line is the maximum length of travel. Okay. So here's another example. This is done in beautiful PowerPoint. And again, these have to be simple diagrams. And the big thing is really being clear if there's an exit, where it is. In this case, you can see 2 big arrows. And then also indicating, I just used a big black box to indicate exit signs. You'll want to just think through where are the exit signs required in a project. And in this case, you can see there's actually 3 on the lower level there. The central one is when you are in the middle of a project, how do you get out? You do need to have signs when there are sort of decision points. Although I think I probably should have oriented it horizontally, but such is life. So the other type of plan that we need to do early on is an occupancy plan. And again, our project is pretty simple, but this is how the plan you use to figure out how many occupants there are in a project. It's what's based on what's called the specific occupancy of spaces. So there's the use group of the building itself. And then within that building, there may be individual spaces that have different specific occupancies, some with more people, some with less. And if you think about it, if you have a project with a storage room, there's probably not a lot of people in that storage room. But if you have a dance floor, there are going to be a lot of people there. So you'll want to use the correct specific occupancy. And that number of occupants is what's needed to determine the number of exits required in the project, corridor width, number of toilets, number of doors, all this kind of stuff. So we need to know that number, and you actually do need to do it early on. So this is actually from straight out of the building codes class. There's kind of a process here. Now, our project is pretty simple. And for this stage, we're just going to do a diagrammatic plan. It does not have to be a 1/32 of an inch scale. But we're going to be given the number of toilets, so you don't have to worry about that. But the big thing is calculating the number of people in there is an exercise you should always do for construction drawings. So this is the table from the building code that is the specific occupancy. Table 1004.1.2, one of my favorites. And again, I'm using the Massachusetts code, so you would want to use the code wherever your project is. But in our case, you're using this one for our project. And look at that. They even have pools in the specific occupant load because they basically have everything, every type of project. This number that we get, there's 2 parts. For the pool itself, there are 50 gross, and it doesn't mean 50 gross people, like, oh, they're disgusting. It means 50 square feet per occupant. Okay, and if you look up in the sort of title for the chart, it says square feet per occupant, and it's gross square feet. Some of these are net square feet. Gross square feet, I'll show you in a second, is something different. So the pool is different than on the deck, and logically it makes sense. You're going to have more people kind of sitting on the pool deck or waiting to get in the water than you are actually having people in the water. At least that must be the logic. So for gross area, it's easy. You take the entire project and you measure it to the outside of the walls. And you include all interior walls, all storage spaces, all circulation spaces, all toilets, everything. So for our project, you just look up that number, and whatever you get, that's the gross area. just FYI, if you have something that is net area, and this is true of, say, assembly spaces of different sorts, that is just the interior space. So you measure the interior face of the walls, and that is what gets you your net area. But anyway, our project is super simple. It's just gross square footage, so we have it easy. Here's an example of a code analysis from a student project a couple years back, the same one that I showed the fire life safety. And you can see they have, this is actually a Revit-generated occupancy legend. By the way, when I'm doing these sorts of projects, if it's a design presentation, I'm not going to be using Revit. But if I know I'm going into construction drawings in a project, I will probably do the occupancy plan in Revit. And the reason being is that it's so much easier if you make changes. And there are always changes. So anyway, doing these color legends is actually pretty easy in Revit, but obviously in our case, you can just, we have one color to do on our entire project. You can just do that any which way you want. I thought I would show, this is an example from a real project that I worked on about 1,000 years ago, and this was an existing building, and we needed to calculate how many, if we needed to add more exits, or make the current exits bigger, which of course is a big expense, especially in this type of building, which had a lot of masonry. So we used a key for the different use groups: assembly, classrooms, storage, etc. And then we colored in the plan and figured out how many occupants are in each space. Again, these were masonry walls, so you pretty much had a good sense of what it was. These were all net square foot, as you can see from the way it was colored in. This was using the computer. And then we could figure out the capacity of each of the egress components and prove to the building inspector or the building official that we did not need to add more exits, which was good because they did not have the money to add exits. In the newer part of the building where it was a stadium or a basketball court, we posted the occupancy. And what that means is you hang a sign that says nobody more than this is allowed in here, and that allowed us to keep the size of the egress system manageable. So anyway, how many exits do you need? Again, this is a given in our project that because of the project type that we're not going to have too many occupants. So probably when we do the calculation, we're going to end up with less than 500. So 2 is the maximum number of exits. And you do that by level, by the way. So in a large project, like an office project, if there's multi-stories, each story has its own occupancy calculation, and then it has its own calculation for all the components, width of the egress system, and all that. Okay. So the other part of the building code that we need to worry about is the accessibility regulations. The big thing with those is that they are part of the Massachusetts building code, and most states do it this way. The Americans with Disabilities Act, of course, applies everywhere, but that is a sort of a regulation which applies after the fact. You can occupy a building and live in it and not be compliant with ADA, and then somebody can sue you and force you to comply. Most states put it into the building management regulations so that you can't occupy the building without complying with these regulations, which is actually good. You don't want to have to add later. And any building element that you have that is subject to accessibility regulations has to comply. So if you have a service counter or an elevator, all of those things have to comply with accessibility regs. And these are things you should be familiar with, things like the angle on thresholds, the maximum change in height on thresholds. All of these are from 521 CMR, Commonwealth of Massachusetts Regulations, the accessibility code here. Probably not news to you, minimum width of accessible routes versus just openings. One thing that often is news to students is that the way that you approach a door does actually determine how much clearance you need on the push and pull side. So something to always check, and we will, after we finish schematics, we'll have a in-class exercise where we make sure everybody complies with all their doors and all that. And again, these are known numbers. It's just a matter of trying to remember that you have to have them infrequently, but sometimes you will run into trouble where the route that you approach a door from makes it so that you can't have clearance because there just isn't space. Typically places with lots of little offices. Anyway, for the most part, again, depends on the direction you're coming at, if it's the push or pull side. So be sure you're vaguely aware of these clearances. And here's a larger version. Those regulations, by the way, apply to all projects. There are even some that apply to residential projects when you're talking about multi-unit type of building. For private residences, there are really no regulations required, although universal design or aging in place are things that you might want to discuss in those types of projects. So there are also accessibility regulations by project type. Okay, so, and I've written two here to differentiate them. The first kind of, 20 chapters of the common CMR 521, 521, not 512, are these project types. So recreational facilities is what our project is. You should read that, and you should read it before finishing schematic design, just to make sure that there's nothing that applies to our project, and I'm going to bet that we are going to find something that applies to our project that we need to consider. This is as opposed to the second half of 521 CMR is all kind of accessibility regulations based on individual kind of building elements, and those doors, floors, those kinds of things you often have in pretty much every project. So, and these are things, if you discover, there's something specific to my project type, in our case, floor surfaces, slipping on floor surfaces is an issue. We're going to want to make sure that we comply. We're going to be trying to control drainage using thresholds and things like that. We can get into trouble. So, and modify your plans as needed. So let's take a look at some of these regulations here. I think I have some of them open. Oh yeah, there we go. So floor surfaces, I'll just zoom in on this a little bit. You can see there's all sorts of things that describe dimensional constraints, or you can just skip straight to the pictures if that's what you prefer. If you have carpet in your project, it has to comply with the following. If you don't have carpet, you don't need to worry about that, right? But if you do, you need to consider that. Gratings, we might have gratings, right? Because of drainage, depends on the type of project you're going to have, and how you articulate your design. So anyway, absolutely check to make sure that there's anything that might apply to you. Now let's take a look at the recreational facilities. There's a large number of things that it complies with, or that they apply to. Swimming pools is what we're worried about, but if you're working on some new project, let's say a radio control facility, I don't know how many of those there are, but anyway, they'll have to comply. Again, non-residential, so if you're doing a residential jacuzzi, don't worry about it. Anyway, swimming, lap pools, diving pools, are subject to this, should be accessible in general. And then I believe you do have to have an accessible lane. Okay, and I know the question came up about, do we need a chair, a lift into the water? And I believe that this is what we're required to do, or at least we have to have one or the other. And you can see there's a maximum slope of 6 and 1, which is actually pretty steep for heading into the water. So I'm not quite sure how they get out of there. That's a pretty steep climb. But that is this is exactly what the accessibility code is required. And I have seen these in public swimming facilities. These railings that basically head right into the water. Okay. The lifting device is probably what a lot of you will opt for. Okay. Either way, make sure you read through this section to make sure you understand what is required. These drawings are super helpful, and as I mentioned in schematic designs, they can just be diagrams. In years past, students have either exported an image file from Revit or SketchUp, as the case may be, and just modified it in Photoshop, Illustrator, whatever you prefer to draw in, or you can literally just print those puppies out and hand draw on them. Although I'm always wary of doing that. Again, it makes making changes that much harder, and so I would recommend the electronic route. And probably for most of you, Illustrator is going to have the graphic look that you're looking for. So that's it for diagrams.